Gravity, Part 1. History of gravity. Even without the knowledge of gravity, we know that what is up will eventually come down. So, how did our ancestors explain this phenomenon? The ancient Greeks believed that the universe is composed of the four elements: earth, water, air, and fire. Each element has a natural place one above the other, so that they are arranged as follows from the bottom to the top: earth, water, air, and fire. A natural motion is when an object moves vertically up or down towards its natural place. Heat rises above the air bubble rises above the water, and stone falls through the water. In 1665, Isaac Newton achieved an understanding of gravity. A famous account of how the notion of gravity came to him was while he was sitting under an apple tree in a contemplative mood. He saw an apple fall from the tree. He thought of why the apple always fall perpendicular to the ground and why not upward or sideways. That is, the apple always falls towards the center of the earth. Newton had an insight. Newton thought of gravity as extending from the center of the earth to the moon. Likewise, he thought that the same force, that is, the force of gravity, is the same force that attracts the apple to the earth as well as makes the moon orbit the earth. Newton made the calculations comparing the ratio of centripetal acceleration of the moon to the acceleration of the falling apple on the surface of the earth. He used the period of the moon to calculate its centripetal acceleration. Also, he assumed that the gravitational force between two bodies is an inverse square of the distance between them, which was known since 1640. In what would become Newton's law of universal gravitation, Newton postulated that there is an attractive force for two masses separated by a distance measured from their center. G is the gravitational constant, m⁴ and m⁴ are the mass of the bodies, and r is the distance between them. Note that Newton's law of the universal gravitation is actually stated only for point particles. What the law of universal gravitation also implicitly says is that a mass exerts a force or attracts another mass, be it the earth on the moon or between two rocks. That is, there is no explicit declaration of the properties of two bodies such as the bodies having a gravitational capability. For a time after Newton, there was no other ideas about gravity, or we can say that there was no problem with the idea of gravity. Then came Albert Einstein. In 1905, Albert Einstein forwarded his theory of special relativity. Einstein had then conceived of relativity, supposedly based from Galileo's relativity. Special relativity is about constant velocity. In most articles, the reasoning behind Einstein's venture into gravity was that soon after publishing his theory of special relativity in 1905, Einstein started thinking about how to incorporate gravity into his new relativistic framework. But somehow, I think that what really happened was that Einstein wanted to extend his idea of relativity to constant acceleration. And what is related to constant acceleration? Constant acceleration relates to gravity, as Newton pointed out of the constant acceleration of the moon's orbit around the Earth. According to Einstein, gravity is caused by the mass curving the fabric of space-time. For the moon orbiting the Earth curves the fabric of space-time, and the curvature of space-time makes the moon orbit the Earth. Put simply, Einstein's gravity is not a force understood by Newton but rather caused by the mass curving the fabric of space-time. There are various images of the depiction of the curvature of the fabric of space-time. For black holes, the funnel image is used. In spite of the supposed successes of the general theory of relativity, the current state of gravity in physics is that quantum mechanics cannot be reconciled with the theory of general relativity and that the Standard Model does not include the fundamental force of gravity. There were two theories that were affected by Einstein's general relativity: quantum gravity theory and the Standard Model. Quantum mechanics deals with the minute world of particles. Einstein's general relativity was said to explain the universe better. Since then, physicists were trying to unify quantum mechanics with general relativity in what is called the quantum gravity theory but were met with failure. The next theory affected by general relativity is the Standard Model. The Standard Model is about the fundamental particles and fundamental forces of matter, where there is a mediating particle for the fundamental force. The theoretical mediating particle for gravity is called graviton. Understandably, since Einstein's gravity is not a force, then this caused a problem as there is not supposed to be a mediating particle for gravity. In spite of the supposed successes of the theory of general relativity, the current state in physics on gravity is that quantum mechanics cannot be reconciled with the theory of general relativity and that the Standard Model does not include the fundamental force of gravity.
Please give proper credit to the author for discussion of his ideas and theories. Thank you.